Online, and hello everyone here. I'm Meliha, this is Jens. I think everyone knows Jens already. I'm a bit newer to this field. Maybe just quickly to my background. I did architecture and did my architecture at TU Wien, my PhD as well at TU Wien, and then moved to ETH Zurich for my postdoc, where I tried to combine my work on material passports with blockchain. So we are presenting together material passports and Web3 for a circular built environment. So quickly to the current situation, the construction industry is the largest consumer of raw materials and also responsible for 40% of CO2 emissions. And this is mainly due to the linear economy model in the construction industry. Therefore, a transition to a circular economy is urgently needed. But one problem is that for existing buildings, there is lack of data on the materials, for example, on the quality of the materials in the existing building stock, and also about the reuse potential and so on. Is there a problem? Yeah. So if we had this information, we would be able to reuse more materials, preserve our buildings, and then have a main contribution to the circular economy. For new buildings, the situation is a bit different. We do produce a lot of data, which can be useful for the transition to a circular economy. One main enabler of a circular economy are material passports. We can also name them digital product passports. There can be a slight difference, and there is also still no consensus on that, but I named it a material passport. And material passports are a digital documentation of the material composition of a building. They can show the allocation of materials within a building, the amount of materials, the share of reusable, recyclable, and waste materials, and also the environmental impact of them, as well as the separability of materials. During my PhD, I worked on material passports for new buildings and for existing buildings. The material passport can have several roles throughout the life cycle stages of buildings. At the start of life, so at the conceptual design phase of buildings, it serves as a rough analysis and optimization tool where you can carry out variant studies, for example, timber versus concrete, and then opt for the better version. Then the material passport B, it can serve as an optimization tool of the selected variant. You can still change the thickness of layers and some materials. Then we have the material passport C. It's more a documentation of the exact material composition. And then the material passport D serves more as a basis for a secondary raw materials cadastre. So we can see what type of materials exist in the stock. Can we reuse them, or do we have to recycle them, or can we preserve this building? For new buildings, we developed the BIM-based material passport, where we had the BIM model in BIM. On the right side, you see the data management and assessment tool. This is where we handled all the material passport and LCA data, and where we also created the material passport in the end. So we didn't store all the information that we need for material passports and LCA in the BIM model itself. There we only had the geometry and the material types and the quantities. And then on the other side, in the data management and assessment tool, we had all other information that we needed to create the material passport. We also generated material passports for existing buildings. This is just one example that we have used. We used laser scanning, and also we did use ground penetrating radar to get information on the material composition of walls and slabs. And what we can say as outcome here is that material passports for existing buildings are a rather challenging task due to lack of information, and also in comparison with the high-tech and state-of-the-art method that we conducted. For the high-tech method, we used laser scanning, ground penetrating radar, and combined this data and generated semi-automated BIM models. The time that we needed and the costs were quite high. Still, the data quality was better than with the state-of-the-art method, where we used existing 2D plans and just on-site investigations. Here, the quality of the data is lacking, but of course it was a bit quicker and lower in terms of costs. So to transfer to the blockchain part of this work is to sum everything up. Also, we can say that in a design stage, if we have a BIM model, usually we do have all information that we need for buildings to enable to assess the circularity of the buildings. But what happens with this data within, let's say, 100 years across the whole life cycle of buildings? Is this data still available? Was it stored in a way that we can still make use of this data in 100 years? Was it maintained, and is it still up to date? So these are the questions that we still have, even though if we create a material passport today, there is still a question if this information will be available in 100 years or 200 years or whatever. So we need to enable a circular information flow. And this is where I hand over to Jens.
So yeah, I think the transition is that circularity of built assets and products is not necessarily equal to circularity of their data. These two things, they need to be the same. They both need to have the circular value flow. And we think that blockchain can actually help in that regard. And we work at the Circle Engineering Architecture Lab together with the material passport example as a good example in the construction supply chain, where blockchain can be applicable and beneficial. Of course, a material passport is not the only way you can apply all these things, but it's actually a really good use case and a really needed one. So in our, we think about the possibility of blockchain in two areas. We first think data needs to be available and trustworthy to the whole value chain over the whole life cycle. And blockchain can help with provenance. We heard about supply chain before, and also access as a case. And we will talk more about access and show you one of the prototypes we built, how we think blockchain can help with access to data. And then we also think that's the main focus of this presentation, but we do think there is also potential that data need to be shared and maintained over the whole life cycle, where blockchain can be beneficial as well. And I have one slide at the end, how that might look like. So we said it's a Web3 prototype. So to understand why Web3 is better than Web2, we quickly need to see what's actually Web2 and how does access control usually work in the internet we have nowadays. In a very simplified way, you have this sort of technology stack. You have a data storage somewhere where it's often operated by third parties. It's mostly a cloud service nowadays. Then we have some access control, which is a server that checks whether your login credentials, like an email or a password nowadays, matches the one stored, and if correct, then forwards the request to the data. So basically, it's also a third-party service. Someone operates this access control. We have some very well-known companies that I think now provide access to most services we use nowadays. So why do I think this is problematic for the built environment lifecycle? We heard it's very long time periods. There are a lot of stakeholders, and data is being produced over the whole life cycle, ideally, and stored in different locations in these different cloud services. But even if you do have a CDE, like the idea to have one data repository, you have still the problems that passwords could be lost. These third-party services, they could go out of operation. Who tells them that, who knows whether the server operator is still there in 50 years, right? The stakeholders that know where the data is vanish. So there is a lot of problems that could happen, and there is just a non-zero chance that your data is not available anymore at the end of the life cycle of the building. If you're lucky, it is. So we think that Web3 actually promises some potential in this regard, and Web3 for us is really about control and ownership of the data. And there are these two definitions that are quite common. One is from the Web3 Foundation, one is this tweet that was everywhere. I don't know if that's the original one. And in a way, it's Web3 is like blockchain plus decentralized data storage protocols put very simply. It's very greatly simplified. And it's not Web 3.0, which is more referred to the semantic web, so machine readability of data. It's something else. It's more about ownership of data. And for that, you need these two technologies. So what changes if you use Web 3? Basically, you exchange certain parts of the technology stack. So your data storage is a decentralized data storage protocol, and your access mechanism is handled by a blockchain smart contract. And the big difference is, even though it works quite similarly, that you shift trust from third parties to the technology. And that's always the promise of blockchain. And that's the general assumption behind. You believe that these technologies will be still there in 50 years, and you can recover this access and storage logic, right? And you don't need to trust all these third parties and stakeholders to recover and have access. So that's the basic assumption. Whether this will be true or not, we will see in 50 years. But so far, it seems more likely. Let's put it that way. So with our prototype, we wanted to see how such an access logic and storage logic could look like. And we came up with two mechanisms. One we called role-based access logic. And it's actually very similar to how it works nowadays. So instead of having a password and an email, you get login through your holding the address. So there is a smart contract checking whether your address is authorized to access a certain unique identifier in a decentralized data storage location. And you get fine-grained access control with that. Access can be also removed from an address. But as of now, it's not so scalable. So authorized users need to add new addresses that are authorized or remove them. So can be not so scalable in my opinion. So the way we implemented it, we used the public permissionless blockchain, the Stacks blockchain. So everyone can join the nodes. The Stacks blockchain is it's been around for a while, but it works together with the Bitcoin blockchain, and we thought that's interesting, and we wanted to learn more about it, so we used it for this prototype. The same thing can be built also with other public permissionless blockchains. And we built a decentralized application that everyone can access and handles with the smart contracts the access logic. And then we have two wallets, and the workflow is actually quite simple. You register the address in the smart contract, and then when wallet B that was registered want to access, the smart contract checks whether wallet B actually has access and forwards the request. So this becomes a bit more clear, I think, when I show you the prototype. So this is our decentralized application, and everyone can log in as long as you have an address. And so it's really decentralized. There is no gatekeeping except the smart contract logic. So what you can do is you upload a file or data to the storage protocol we used. It's called Gaia, and then you can allow sharing with the decentralized application. So now the decentralized application can handle access control, and then you can log in with your wallet and register through the front end the addresses that should have access. And this triggers the smart contract execution. So basically, you execute the function add data accessor that adds the new address, and the smart contract now knows, okay, this new address has access. And you can then log in with the address B that was registered, and you actually have access to the file. And if you now choose an account that has no access, because you can log in because it's a decentralized application, but it checks in the smart contract that you don't have access and you won't get the forward, you can't access because the data is encrypted. We had also that's very similar how it works today, just on a decentralized, in a decentralized manner. We also used tokens to hold the access rights. So we implemented token-based mechanism. So whoever holds the token has access to the data. And we found this a very interesting and new way how you could distribute access rights. So it also allows you to prove access of something by holding the token without actually signing a transaction, which is quite useful in some cases, maybe. This goes towards ownership of data, right? However, we find it a bit more difficult to control access at the individual address level, because I could just send it to you and then you have access. How to avoid, I mean, it's easy to distribute access, but then how to control it, it's maybe a bit more difficult. And this is something that could be researched further. I don't know if I need to show you the video. It works basically the same. You mint the token for the data, and then you can send around the token. How much time do we have left? No. And basically, whoever holds the token, so if then the new address holds this token ID number, then he can access the data. So that was our data access prototype. We published that for the EC3 conference, so you can read the paper if you're interested more. And I quickly want to show where this could go. So this allows, for example, access, and then we do have some idea how ownership markets and incentives could help to control and maintain data. So this goes in the direction of no one's one that Una is working on. So what if the data is not controlled by humans anymore, but actually the infrastructure itself? So what if the house actually owns the data and controls the data? This would become feasible if you have such a decentralized data technology stack. Then there might be possibilities to incentivize circularity, maybe through these tokens, micropayments to maintain and reward data contributions, and also maybe new business models through trading these data. So the tokens could also be sold instead of just sent to someone, for example. All right, so to conclude, maybe you want to conclude your first part.
Yes, so to conclude, the generation of material passports for new buildings is a pretty straightforward task. However, for existing buildings, it's a rather effortful process. And one important thing is that material passports created today would not be of help in future if we don't have access to the data and if it's not maintained and stored in a way that we can use this data in future.
Yeah, and we find that this Web3 approach to data management is very interesting for construction, because you deal with with time periods that are so long and so many different stakeholders. We built this prototype to show that it's possible, but there are, of course, a lot of technical challenges still, and we can discuss that in more detail if you're interested. But I think there is a lot of potential here. We also have the prototype open access, so you can access it, you can play around with it, you can extend it, whatever you'd like to. You just need to refer to us when you do so. All right, thank you for your attention.